Today we're going to look into details in various numbers that we have in Python, integers and float. With a integer, it basically doesn't have any extra numbers past the decimal point, and a float is a number with a decimal point. We're going to see how we can do a number of things, and we're going to first kind of peek at these floats. And one neat thing about Python, if you're having to deal with numbers in scientific notation, you could basically just put in scientific notation. Now I'm going to have to fix that there. Put in scientific notation, and it will automatically make that number a float. So let's check this out really quick. Let's get a name for this program. Okay. So you can see it automatically determined that, well, this is scientific notation. We're going to make it a float. We threw in for the scientific notation 3.387 10 to the 7th power. And voila, that is what we got as a result. Let's look at another example of something really common in the Python programming language that you might end up doing with a float. So we're going to assign our own float here, and we know it's not an integer. So if we had another one, we just call this, put a couple b's in there, equals 3. Python would look at that and assume that you want that to be an integer over a float, because it didn't see a decimal point in the number. But let's do this. Let's print this number out. Okay, so we have the first one, but then the second one, and it prints it out. But in most cases, when you're given the result back to someone, they're going to ask you, they're going to want you to round. They might not want all these numbers, and keeping all these numbers might be significant. And if you're doing some sort of multiplication earlier on, and it's a larger program than just us assigning a number and printing it, maybe these numbers multiplied a whole bunch of times over will get your result. Possibly higher. So you usually want to keep the precision of the floating point through most of the program, but you may want to, towards the end of the program, when you give the actual result, you might want to do some rounding, and that's where the round function comes in. So we're going to do another print again, and we're going to use our same number that we assigned up here, but this time we're going to use round, and we're going to round it to only 2 digits past the decimal place. So you put the 2 in there. You can put 1 for 1 digit. You can put 5 for 5 digits. So you have many options too, or you could just leave this parameter blank, and it will round it to the actual whole number. Okay, so let's comment out that first part. we are done. We are done with the first part, and we're gonna want to just hide it away, get it out of view. So we're gonna put some comments on here, and we're gonna run this. And we have an error. Well, let's fix that. Okay, so that's looking better. And we can see we rounded it off to 2 digits past the decimal place, and that's pretty common. Depending on what you're doing, we might have to round it, to a whole number, or we might 1 digit. But 2 digits is truly pretty common. Now we're gonna peek at a couple of functions. We've been using them in the past. And the first one we're gonna look at is the integer. So we're gonna get that same number that we had above num2, which was a float, and we can use this int function to convert it to a float, and we're going to call this float num3. And let's run that really quick. Okay, so now we have a num3 that's an int. It's all based off the same number. And let's say you want to convert that back. So what we're going to do, we're going to make a num4, and we're going to say num4 equals the float function with num3 in it. So what we're doing is we're getting that integer that we made above, and we're turning it into a floating point number. So let's look at what a result would be on this one. Okay, so we're looking at a result, and we can see that now we have a decimal point and a 0. And through this process, all of this is actually from the same number, but we did rounding, we converted it to an integer, and when we converted it to an integer, since the integer does not store anything past that decimal point, we lost all the original values here. So we have 0. That's one thing you got to be careful if you're doing a lot of conversions in programming in your program. You got to make sure you don't throw something into an integer and put it into integer form and then try to put it back in float if you want to have anything more than a whole number, because once we throw it into integer, there's nothing past the decimal point. It's all lost. So for us to get any of these other things past the decimal point, we'd have to go earlier into the program before num3, which became an integer. Okay, so one of the things that, while going over the book, that I noticed that seemed a little confusing to me, and they didn't probably, I mean, for the most part, the book is great about explaining anything. I love this text, but they got down into some technical details, and they didn't really explain themselves. They said numeric data type integer, it's not going to be anything over, like it was like 2 billion, and positive 2 billion something to negative 2 billion something. And if that were the case, and that's all you could do for integers, this, I mean, we might have some issues, because in real life we deal with sometimes with really large numbers that go more than 2.5 billion. And what let's get their value, and let's get their value. So we're gonna import sys, which is going to import this this module that has a whole bunch of things that you can do from sys, and we're going to go and grab the maximum size. Let's run this really quick, and this corresponds exactly with the maximum value that the book says integer can be, which internally it is true, but when you run the program, you could go way over that value, and I'm going to show you a sample of that, and then I'm going to tell you, what's going on inside the actual Python itself. So let's get a really big number. Okay, so we're talking 3 billion, and that's above the number. Let's verify that by just printing this out. Let's make sure I get all my zeros, and I do. So we're gonna press it past the limit of integers, and then we're gonna print. We're gonna print it, and we call it num5. So we're gonna print num5 in. Then beyond that, we're going to use another function called type function, which the text touched on, and we touch on in a few of the videos, previous videos that we had. So let's look at this. Okay, that looks good to me. We're going to run it. Okay, so just right up here, I go beyond the maximum value of an integer, but when I use the type of it, it says integer. And what happens is, behind the scene, and like I said, this it was a little confusing in the text why they expressed it like that, is that the first allocation to an integer is that can go up to that max size, but then Python realized, oh, we're going to just throw another one and make a long integer, and the bigger the number gets, it's just going to give another allocation of it's going to just throw another amount of bytes in there, another 4 bytes until it meets the needs that you have in your program. So don't worry if you're using large numbers above 3 billion or whatever. You're going to be safe, because behind the scenes, Python's going to magically come there and say, oh, this is a really big number, let's just allocate more space so you have more range. So the range that you see in the book is really just the first allocation that Python gives internally, that we as programmers of Python don't need to know about, basically, because it's going to handle it all for us behind the scenes. Now let's examine the math module. I'm gonna just close this out. It's getting kind of cluttered, and let's start fresh. New file. And to import any module in Python, we use import, and we're going to do the math module, and we're going to give it alias, although math is fairly small word, we're going to make it even smaller. So we're going to give it an alias of M. This is a pretty handy module for doing a number of things and calculations. It supplies a fair amount of functions and constants that are used in various scenarios involving math. So let's first, I guess, look at the power function. And what that does is, given a number, and I'm going to give 10, I can raise it to the power, given power, and I elected to put it 10 to the second power, which should be 10 times 10, which should be 100 if everything goes okay. And now we're going to check to see if everything goes okay. Okay, so what we're expecting to see, if this Python math function did work properly, we would expect to see 100. So let's run this. Oh, we need to give it a name that's not already used. We have quite a few things in here. So let's go with that. And we did get 100. So let's move on to another one that's fairly common. We're going to say num2 equals math function, the square root. Let's go for the square root of 16. We'd do an easy one. So one we should be able to do in our head. The great thing about these functions, we could let Python do the complicated ones, the other ones that are involving fractions and whatnot, that are just really difficult to try to put together in your head. You could have Python just do that for you. This one's fairly easy. The square root of 16, which we know will be, or should know, will be 4. We're gonna run this. And oh, I did not have an equal sign, so we're gonna run it again. And this time it should be a little better, and it is. Okay. And we have 4. So that's good in that respect, that it could do that. But let's throw some here a little more nutty, like 77.54. Okay, there we go. This is one you're probably not gonna be able to calculate in your head readily. If you are, bonus to you. That is very very wonderful talent there. But Python should be able to let anyone calculate these square roots of various difficult floats in their head, and do it nicely for you. Okay. Now, another really cool thing about it is that there's various mathematical constants. And one of them that we run into often when working with circles is pi. So I'm just going to print the constant pi here, and what you get is a number that you should be relatively familiar with. You get pi. In having pi, you could do lots of things, and we're just going to do a quick little sample of all the many things you can do. Let's set radius equal 18. Let's say we want the circumference, and we know that that's going to be pi times radius times 2, and let's print this. And then it will give you the circumference. Another thing that is you may run into a lot of times is floor and ceiling. So we're going to examine those right now. We're going to enter, I guess, assign a number. We're going to go 3.888121. So we have a floating point number, and we want to print the floor so we could call on our math function called floor, and what the floor does is puts it down to the nearest going down the whole number. So the result of this should be 3. So it's gonna go and it's not gonna round it up. It's gonna always go down to the nearest whole number. But we also have the ceiling to complement floor, and the ceiling will bring it up to the top, matter what. It's gonna should turn that to a 4. So let's use that. Let's use ceiling, and let's see as a result what we get. This looks like we aren't gonna have any syntax errors, so let's give it a run. Okay. So what happened here is that we assigned a floating point number. We wanted to take the floor of it, which should be 3, which is indeed 3, and the ceiling, which is essentially just a round up, and which would be 4. Now, one more last, and there's plenty of more of these. You could look through the Python documentation to see everything that we have out there for this. Another one that I enjoy is the GCD. Given two numbers I'm sure this would be a popular one in junior high math, and we're trying to find the greatest common divisor of 10 and 15. Would it be 10? If it was 10 and 20, it would have been 10, but with 10 and 15, so it should be 5. So we're gonna check Python, which I'm sure Python is going to be correct, and we should get 5, because that really is the greatest common divisor between 10 and these two numbers, 10 and 15. So let's run it. And indeed, we do have 5. So those are some of the many functions and constants that are provided in the math module. And to restate myself, if you're interested in more, check out the Python docs. There's plenty more numbers for more things with geometry, trig, you name it, it's out there in the math module.